Okay, hi Addy, welcome to lesson number 85, and today's lesson, this is going to be awesome because this is something new. I don't think that you've done this before, but I love this math technique. This is a really cool technique on how to solve problems, and you're gonna really love it. We're gonna use it definitely many more times in the future, okay? But first you're gonna do your facts practice, and you have to do your liquid measurement, and this is test L. You're gonna have 5 minutes to do it, and you're gonna hate me because I do not have a 5-minute timer in this lesson. So you just have to pause the lesson right here and set up your own 5-minute timer and do your liquid measurement test, test L, and do as much as you can in 5 minutes, okay? All right, I'll let you pause it here and do that. See you in a few. Okay, when you come back from that, we're gonna go over this comic. And here you can see a bunch of doctors or researchers. They're wearing white lab coats, and if you read this, it says backwards, sort of in mirror talk, it says primate studies. So it sounds like they're studying monkeys or something. And look at someone saying, "For crying out loud, gentlemen, that's us. Someone's installed the one-way mirror in backwards." So they've been just sitting there staring at themselves. It's really funny. Okay, and it makes you wonder how long they've been doing that, because look, there's a clock. There's a clock in the mirror too. It looks like it's, 1:35 maybe p.m. How long have they been? That's hilarious. Okay, let's do mental math. Now, for this mental math, we're gonna count up and down by fives, and that sounds super easy, right? But you're gonna start at -25, go all the way to +25, and we have to go up and down. I didn't draw a number line in this time, so let's just see if we can imagine one. Here's 0, here's -25, and here's +25, and we'll just see what happens, okay? So we'll start -25, -20, -15, -10, -5, 0, 5, 10, 15, 20, 25. Now let's count down. 25, 20, 15, 10, 5, 0, -5, -10, -15, -20, -25. Sweet, we did it. All right, let's do the rest of mental math. We're gonna do A, 50 times 50, write your answer. So I would do 5 times 5 and get 25, and then add all those zeros to my answer. All right, and while you're doing that, we have some pictures of storms to look at, because you know it's been really stormy at our house, enough to make us lose power 2 times, so super fun. All right, let's do B, more storms. 1,000 minus 625. Write your answer. Really think about these. If you need to pause the video, make sure you do it, because remember, you're trying to get 90% or above on this. Okay, C is going to be 4 times $3.99. So remember, do 4 times $4. Then you're going to have to subtract 4 cents from that, right? Okay, D, we are going to double $1.25. Okay, E, was he flipping us off in that video? If he was, I apologize. I did not notice that before. I don't know if that's a flip off or not. Let's not look any closer. Okay, E, 7.5 divided by 10. So is this number going to get bigger or smaller? Okay, this is quite the storm here. Wouldn't want to be in that one, huh? Okay, F. This storm actually looks like they did time lapse, and it looks pretty dang awesome. That would be really fun to see, as long as you were somewhere safe, right? F, we're going to do 20 times 35. I would maybe double 35, because it would be 35 times 2, and then add that 0 in at the end. Okay, G. This is a long one. We're going to start with the number 7 times 7. Now add 1. Divide by 2. Subtract 1. Divide by 2 again. Multiply by 5. and divide by 2. Write your answer. Okay, H, Happy Hands Club. We are going to hold our hands 1 yard apart and then 2 feet apart. You know what's funny is I always remember this one because I always think of my drawing that I did where you've got like a foot. Oh, I like to draw all the toes. So there's a foot, there's a foot, there's the ankle, see? But this person has 3 feet. I don't know why they have 3 feet. Maybe they're a monster. And they're standing in a yard. And so it's a grassy yard. And so I imagine 3 feet in a yard. And it turns out that's how many feet are in a yard. And so if you start with a yard and then go to 2 feet, you're going to go from big to small, right? All right, next one. Let's do problem solving. Here we go. Houston, we have another problem. You've got to solve this one. Here is part of a multiplication facts table, but one number is wrong. What is the wrong number? I shortened that word. Okay, so you know what a multiplication table does. You have a number over here, like maybe 9, a number over here like 9. 9 times 9, where they meet, that's going to be 81, right? But it has to be 9 times something else in all of these other things, right? So I don't know if those 9s are right. I don't know. Maybe the 81 is the wrong number. Maybe. I don't know. So you sit and look at this. See if you can put some, multiplication tables, maybe like 6 times 8 here, because that makes 48, and see if you can make it match with something else. Or maybe you can put the 8 down here, right? And I don't know. You figure it out and see if you can find out which is the wrong number. Okay. While you're doing that, let's go to the new concept. All right, this is where the fun begins. Are you ready? This is going to be so fun. I can't wait. Okay, so let's say you have 2 fractions like this. 1 fraction here, 1 fraction here, and you're trying to find out if they are equal or equivalent fractions. There is a super cool way to do this, and that's to do the cross products. How do we do cross products? Okay, let me get this. We are going to cross multiply. So we start at the bottom of one side and multiply it by the top of the other. And at the bottom of the other side and multiply it by the top of the other. So when you cross multiply, you are doing like a big X. 4 times 6, and that's going to be 24. And then you're going to do 8 times 3, and that's going to be 8 times 3 is 24. So what's cool about this is, check it out. We ended up with a 24 here and a 24 here. If these numbers are the same, you've got equal fractions. Oh my heck, isn't that so cool? So 3 times 8 is 24, 4 times 6, 24. You make an X with it. I love it. So both cross products are 24. And here's what you need to know. If equal fractions, let me just say it the way it's written. Equal fractions have equal cross products. So if the cross products are the same, those 2 fractions are equivalent. Oh, so cool. All right, let's jump into some of these examples. Example 1, don't animal cross me, son. Yeah, we're doing a lot of crossing of products today. I got to get that out of the way, though, because it's distracting. It says, use cross products to determine whether 3/5 and 4/7 are equal. So to do it, we have to multiply the numerator of one by the denominator of the other, and the denominator of the one by the numerator of the other. So to make it not confusing, I'm going to grab these and write it in a different way. Okay, so it's going to be 3/5, and I'm used to putting an equal sign there, but you don't have to because it might not be equal. So I'm just going to erase it because it might not be equal. Now let's look at the cross products. I'm going to get a different color so we can do it. 5 times 4, what is it? 20. 7 times 3, what is it? Oh, That's 21. Oh, that is not the same number. 21 is not the same as 20. So these fractions are not equal. Okay, so now we know. Now, they're going to explain something to you at this point in the lesson. This is not just a magic trick. There is mathematics behind this. It seems like a magic trick because it's so fun and it's easy and you do cross products, but it's not a magic trick. This is what you're really doing. You're taking that first fraction, 3 over 5. And when we what you're basically doing is you're renaming both fractions with common denominators. And so the way to get common denominators here is to multiply it by another fraction, which is equivalent to 1, equivalent to the number 1, because, 7 over 7 makes the number 1. 5 over 5 makes the number 1. So what you're doing when you multiply this out is multiplying the numerators 3 times 7, which is 21, over 5 times 7, which is 35. And then for the bottom one, what you're doing is let's multiply those numerators. 4 times 5 is 20, and 7 times 5 is 35. So you're basically changing them into fractions with common denominators because you've got a 35 and a 35. And now you can easily compare the two fractions because you've got this 21 and you've got this 20. And then you can ask yourself, are those the same number? Are they equal? And obviously 21 over 35 is not the same fraction as 20 over 35. And if you look back, that's what we got when we cross multiplied. You're just kind of taking a shortcut. So you did 5 times 4, which was 20, and we did 7 times 3, which is 21. So you're basically are comparing fractions by getting common denominators. It's just a shortcut to doing that. Okay, but it's such a cool shortcut and it's useful for way more than this. And I'll show you how it's even more useful in a second, okay? So let's do it one more time. You have to try, okay? Example 2. Do these two ratios form a proportion? When they ask this question, they're asking us, are these ratios equivalent? Are they equal? So we have 8 over 12 and 12 over 18. I'm going to erase this comma because I'm going to be comparing these by cross multiplying. So I'm going to take 12 times 12. If you need to, well, you know what that is because you know your 12 times tables, but this is 144. And now let's do the other crossy, 18 times 8. So if you multiply 18 times 8, now I would need a calculator for this one, but turns out you get 144. So this is so cool. If these numbers are the same, then we know that these ratios do form a proportion. It means that they are equal. So I can erase that crossy and put an equal sign right there. If they have equal cross products, then they are equal or equivalent ratios, and that means they form a proportion. Okay, super cool. You can also use cross multiplying to answer an equation or to solve a term that's missing. Let's try that for an example. This is an example 3. Okay, not so fast. There's one more challenge. So don't think that you know all of this already. We got to practice one more thing. This is example 3. And the question is, 6 is to 9 as 10 is to what number? So the M represents our missing number. So if we were to cross multiply here, we would do 9 times 10. And I'm just going to write it out in a little bit of a different way, okay? So I did, well, let's get a different color. Okay, so we did 9 times 10 is equal to, and then grab your other crossy, 6 times M is equal to 6 times M. So see how I did that? We have 9 times 10 is equal to 6 times m. So we cross multiply and we can set it equal to each other because we know that these proportions or these ratios are equal because they put an equal sign there. So 6 is to 9 as 10 is to what number? You can solve that by cross multiplying. This is how you do it. 9 times 10 is equal to 6 times m. Now we can do 90 is equal to 6 times m. So 6 times what number is equal to 90? The way I solve that is I divide 90 by 6. And that's going to give me m. And it turns out 90 divided by 6 is 15. So m is equal to 15. So cool. So if we go back here and we fill that in, 6 is to 9 as 10 is to 15. You can always check your answer by cross multiplying. This is going to be 90. 15 times 6, 90. Easy peasy, right? So cool. Let's do example 4. Now you're starting to feel good about this, right? So this one is the same as that one, except it just writes it in words and the missing number is a little bit different. So let's jump right in. 15 is to 21 as what number is to 70? Now when they give you these numbers, you have to write it in order of how they give it to you, okay? So it goes like this. 15 is to 21 as is my equal sign. As what number? We're just going to put a W for what number. As what number is to 70? Read the problem again after you wrote it to make sure you get it right. 15 is to 21. 15 is to 21 as what number is to 70? Perfect. We did it right. Now, easy peasy. We're just going to cross multiply. Let's do this. Well, let's do this one first this time. 21 times W. It doesn't matter which one you cross multiply first. It's going to be equals. 21 times W is equal to, let's grab the other, 70 times 15. 70 times 15. Okay, so now we have an equation, and you are used to solving these equations, right? So what is 70 times 15? If we multiply that out, oh, actually, they don't multiply it out. They show you a different way to do it, is to kind of simplify. So let's do it their way. They're saying if you want to isolate the W by itself, you're going to have to multiply this out and then divide by this guy. So they just grab this and put it here to divide by that. Okay? And now we know that W is going to be 70 times 15 divided by 21. And then they're like, well, we can actually reduce this fraction. What if we divide everything by 3? By 3? How do they reduce it? Does 7 go into everything? No. Does 20, let's see. I don't know how they reduced it. Anyway, they reduced it. You tell me how they reduced it, because they turned the 70 into a 10, so they must have divided by 7. Oh, yeah. Okay, they divided the top and the bottom by 7. So they crossed out the 70 and put 10, and they crossed out the 21 and put 3. And then they noticed that 15 can be divided by 3. So instead of the 3, they put a 1, and they crossed out the 15 and put a 5. That's what they did. Okay, so that's how they reduced it. And that way you end up with 10 times 5, which is 50 over 1, which is just 50. And so that means that W equals 50. Okay, so you could do it that way, or You know what? If that is getting too complicated, because that was a little bit complicated for me, you can literally just get a calculator and plug in 70 times 15, and then whatever you get for an answer, divide it by 21. Okay? But if you don't have a calculator around, you can reduce that fraction in whatever way is easy for you. All right, guess what, Addy? That is the end of your lesson. I know it was super fun today. I'm going to do something really mean and get you stuck on this song for the rest of the day, right? Because F is for friends who do things together. U is for you and me. N is for anywhere and anytime at all. Down here in the deep blue sea. Okay, have a great day. Sorry that song's going to be stuck in your head, but it's going to be stuck in my head too, so we're even. All right, love you, Addy. Bye.